Hello everybody, welcome into another lesson. So today we are going to do part 2 of using matrices to solve a 2 by 2 system. So once again here we have our 2 variable system of equations where you have various coefficients on your x and y variables, and since you have 2 equations you'll end up having a 2-row matrix where you form your augmented matrix by pulling the coefficients on the x and y variables in each row, and then to the right of the augmented line you'll put what each of these equations is equal to. Well, in the last lesson we talked about just the row echelon form. We didn't talk about this reduced row echelon form. We just did straight row echelon form, which is nice. It enabled us to still find values of the variables for one variable, but we had to use back substitution to find the other variable. This reduced row echelon form will enable us to directly find the value of the variables. So reduced row echelon form is different in the fact that to the left of the augmented line you're going to get what's called the identity matrix. This is the identity matrix for a 2 by 2 system, since that's what you have. So in the top row your first digit is still a 1. The leading digit in any row is always a 1, but every other digit in the row is a 0. So that 1 here would represent your x value. That 1 down here in the second row would represent your y value. That would be the coefficient on the x, the coefficient on the y. So here, the reduced row echelon form, notice, is the identity matrix on the left. This tells you x equals A, y equals B. You straight up got your x and y values. No back substitution required. So the trade-off is initially you're going to do a little more work with your matrices, but you're not going to have to do back substitution. And you're going to see it's actually a little nicer to do this than it is the old way we did it with just basic row echelon form. So in row echelon form, in the first row, the first digit's a 1, always a 1, and then the second digit is a 0. In the second row, your first digit's still a 0, but your second digit's a 1. So your first leading 1 in the first row, you have a 0 to the right of it and a 0 below it. In your second leading 1 in the second row, you have a 0 to the left and above it. If the matrix isn't like this for your identity matrix, if it's anything except for that, it's not in reduced row echelon form. So let's do some examples here. Let's show you how reduced row echelon form is going to work out for solving these systems. So we have here for the first system 6x plus 4y is equal to 8. In your second system you have 3x plus 3y is going to be equal to 9. So there's your system. 6x plus 4y equals 8. 3x plus 3y equals 9. Like we did before, let's put this into a matrix. 2 equations would mean 2 rows. So take the 6 on your x, the 4 on your y, and then form your augmented line, and to the right of that you'll put that 8. Now for your second row, take the 3 on the x, the 3 on the y, and then take the 9 and put that to the right of the augmented line. Now we got the matrix that represents the system. And just like before, our very first goal is to get the first the first digit in the second row to become 0. So if we take the negative of row 1, whoops, I'm writing that wrong. I'm jumping ahead of myself. The negative of row 1 plus 2 times row 2, that'll make that first digit in the second row become 0. So let's go ahead and do that right now. So we're going to leave the first digit, we're going to leave the first row alone for the time being. And then, let's see, so negative of 6 plus 2 times 3, which is positive 6, negative 6 plus 6 is 0. Alright, so the negative of 4 plus 2 times 3, which is 6, negative 4 plus 6 is positive 2. And then you have negative 8 plus 2 times 9, which is 18. Negative 8 plus 18 is going to be 10. Alright. Now, the next goal we have here is to make the second digit in the first row also become 0. We'll reduce all this in a minute, but what I can do to make that second digit in the first row 0 is take negative 2 times row 2 and add that to row 1. And then the second digit in the first row will become 0. So let's go ahead and do that. Negative 2 times 0 is still 0, plus 6 would give you 6. Alright, negative 2 times 2 is negative 4, plus 4 is 0. Alright. Negative 2 times 10 is going to be negative 20, plus that 8 would be negative 12. And then you still have your second row of 0, 2, and 10. We're almost there, but not quite. This is still not in reduced row echelon form. In order to have reduced row echelon form, we got the zeros in place, but the leading digits have to be 1. So that means we need to take 1/6 of row 1, and then in row 2 we need to take half of row 2. So we're going to do both of those at once because you can. So 1/6 of 6 is 1, 1/6 of 0 is still 0. 1/6 of negative 12 turns into negative 2. Alright, 1/2 of 0 is 0. 1/2 of 2 is going to be 1. 1/2 of 10 is 5. Now you have this matrix in reduced row echelon form, which is the identity matrix on the left. You have a direct x value of negative 2, so x would equal negative 2. You have a direct y value of 5. So the ordered pair that would be the solution to this system is going to be negative 2, 5, which would be the point where these two lines intersect, would be at the point negative 2, 5. And I got 8 more examples here. Alright, so let's see. We have x plus y equals 2. Then we have 7x plus 8y is equal to 21. So there's the next system. X plus y equals 2. 7x plus 8y equals 21. Let's form the matrix now. First row, we have 1 on the x, 1 on the y. Then to the right of that augmented line, we'll put that 2. And then second row, you have 7 on the x, 8 on the y, and then you have 21 to the right of the augmented line. So there is the matrix that represents this system. We want to make the the second row, the first digit, a 0. So if I take negative 7 times row 1 and add that to row 2, I can make that happen. So let's do that. Row 1 is being left alone for now. Now let's deal with the row operations. Negative 7 plus 7 is going to be 0. Negative 7 plus 8 would be positive 1. Negative 7 times 2 is negative 14, plus 21 would be positive 7. Alright, so we've reduced row 2 enough. Now we just need to get the second row, the first row, the second digit, to be a 0. So if we just take the negative of row 2, add that to row 1, we'll make that happen. So negative 0 plus 1 is still 1. negative 1 plus 1 turns into 0. Negative 7 plus 2 is negative 5. Then you have your second row, which you can just leave that alone. So now you have it's reduced row echelon form. You have the x value, which is negative 5. You have the y value, which is 7. So the ordered pair that represents the solution to this system would be at negative 5, 7. That is the solution to this system of equations, would be negative 5, 7. All right, next one. Alright, so we have this system here with x plus 2y equals negative 9, negative 2x minus 3y equals 14. So we'll go ahead, set up the matrix. So first row we have the 1 on the x, a 2 on the y, and then to the right of the augmented line you'll put that negative 9. Second row, you have a negative 2 on the x, a negative 3 on the y, and then a 14 to the right of the augmented line. So there's your matrix. Now the first thing we want to do is make the first digit in row 2 a 0. So if I take 2 times row 1 and add it to row 2, I can make that happen. So now let's do that here. So row 1 for the time being is going to be left alone. Alright, so 2 minus 2 is 0. 2 times 2 is 4, minus 3 is 1. Alright, 2 times negative 9 is negative 18, plus 14 would be negative 4. So we've reduced row 2 plenty now. Now the next goal is to make that second digit in the first row also 0. So if I take negative 2 times row 2 and add that to row 1, I can definitely make that happen. So negative 2 times 0 is still 0, plus 1, that'll keep it 1. Negative 2 times 1 is negative 2 plus 2 is 0. Alright, so then negative 2 times negative 4 is positive 8. Minus 9 is going to be negative 1. And then you still have your second row. So now we have this in reduced row echelon form where x equals negative 1 and then y equals negative 4, giving you the ordered pair as negative 1, negative 4, which would be the solution to this system of equations. Negative 1, negative 4. Alright, 6 more, then we'll be done. Alright, so we have this system here of x minus 3y is equal to 5, negative 2x minus 4y equals 20. So let's go ahead and set up our system, set up our matrix here. 1 on the x, negative 3 on the y, then to the right of that augmented line, put your 5. Then you have negative 2 on the x, negative 4 on the y, and then 20 to the right of the augmented line. Yeah, making sure I got those right. Okay. Well, what I can do to make our lives easier, in the second row we see that all these numbers here, the -2, the -4, and the 20 all have a common factor of 2. So why don't we take half of row 2 just to start with? Just do half of row 2. If you do that, you'll still have 1, -3, and then 5 in your first row. But half of -2 is -1, half of -4 is -2, half of 20 is 10. Much easier to work with, because now that we've done that, we still want to get the first digit in the second row to be 0. We can just straight up add row 1 to row 2 and make that happen. So we're going to leave row 1 alone for the time being. So 1 minus 1, that's 0. -3 minus 2 is -5. 5 plus 10 is 15. Alright, so good. We have a 0 in the first digit in the second row. Now the next thing you're going to want to do is go ahead and start by making the second digit in the second row a 1. It's a -5 for your leading digit in the second row. We need to make it a 1. So you're going to take -1/5 of your second row. So let's go ahead and do that to make your leading digit a 1. So first row is still left alone for the time being. Sorry, so -1/5 is 0 is 0. -1/5 of -5 is +1. -1/5 of 15 would be -3. Alright, so now we've reduced the second row enough. Our last goal here is to make the second digit of the first row also a 0. If I take 3 times row 2 and add that to row 1, I'll be able to make that happen. So we'll go ahead and do that now. 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3, minus 3 is 0. Alright, 3 times -3 is -9, plus 5 would be -4. And then you still have the second row, 0, 1, and -3. Now it's in reduced row echelon form, which would give you a direct x value of -4 and a y value of -3. So the ordered pair that's the solution would be -4, -3. And there is the solution to this particular system, -4, -3. All right. Let's see here. 3x plus 2y equals 2. 5x minus 6y equals 50. So there's your next system. 3x plus 2y equals 2. 5x minus 6y equals 50. Let's go ahead and start with our matrix. So take the 3 on the x, the 2 on the y, and then take that 2, put it to the right of the augmented line, and then take the 5 on the x, the -6 on the y, and then take the 50, put it to the right of the augmented line. And there's your matrix. Alright, so this is going to be a little bit tougher because we're going to have to do a couple of row operations, but the goal's still the same. You want to make your first digit in the second row a 0. If I take -5 times row 1 plus 3 times row 2, that would make my first digit a 0 because negative 5 times 3 is negative 15 plus 3 times 5 is positive 15, which would make the first digit a 0 in the second row. So let's go ahead and do that operation. Leave your first row alone for the time being. Alright, so negative 5 times 3 is negative 15 plus 3 times 5, which is 15, turns that to 0. Alright, negative 5 times 2 is going to be negative 10. 3 times negative 6 is negative 18, so negative 10 minus 18 is negative 28. And then negative 5 times 2 is going to be negative 10. 3 times 50 is 150, so negative 10 plus 150 is 140. Well, we have the first digit in row 2 as a 0, and we have our leading digit now as a negative 28. Well, that leading digit needs to be positive 1, so we're going to have to take negative 1/28 of row 2. Let's go ahead and do that right now. If we do that, you're going to still leave row 1 alone for the time being. So negative 1/28 of 0 is still 0. Negative 1/28 of negative 28 is 1. Negative 1/28 of 140 would be negative 5. Alright, so the leading digit in the second row is a 1. Next thing we have to do is make the second digit in the first row a 0. So if I take negative 2 times row 2 and add that to row 1, I can make that happen. So, alright, negative 2 times 0 is 0, plus 3 is still 3. Let's expand this a little. Alright, negative 2 plus 2 is 0. Alright, negative 2 times negative 5 is positive 10, plus that 2 would actually be 12. And then you still have row 2, which we're leaving alone now since it's already reduced. Okay, the last thing we need to do, since the leading digit in the first row now is a 3, and the other digit's a 0, which is great, that's what we need, but the leading digit in the first row should be a 1. So we need to take a third of row 1. Let's go ahead and do that. So a third of 3, of course, is 1. A third of 0 is still 0. A third of 12 is 4. And then you have row 2, 0, 1, and negative 5. So now this matrix is in reduced row echelon form, giving you a direct x value of 4 and a y value of negative 5. So the ordered pair that's going to be the solution in this case is going to be at the point 4, negative 5. So 4, negative 5 would be the solution to this particular system of equations. And I should have 4 more problems, then we'll be done for this lesson. So there is our next system. We have x plus y equals negative 1, 7x plus 9y equals negative 19. So let's go ahead, convert this to a matrix to start with. So take your 1 on the x, your 1 on the y, and then to the right of that augmented line, put that negative 1 there. Second row, take that 7 on the x, the 9 on the y, then put that negative 19 to the right of the augmented line. So we now have our augmented matrix. And of course the goal is to get the our first goal at least is to get the first digit in the second row to be 0. So if I take -7 times row 1 and add that to row 2, I'll make that happen. So for now, leave row 1 alone. That'll stay the way it is. Okay. So -7 plus 7 is 0. -7 plus 9 is 2. -7 times -1 turns into +7. Minus 19 turns into -12. Next thing I would do, because it's great you have the first digit in the second row is a 0, next thing I would do is make that leading digit a 1. So we just need to take half of row 2. So let's go ahead and do that real quick. So still leave row 1 alone for now. Alright, so half of 0 is still 0, half of 2 turns into 1, half of -12 is -6. Alright, almost done. Next thing we need to do is make the second digit in the first row a 0. So if we take the negative of row 2 and add that to row 1, we can make that happen. Alright, so -0 plus 1 is still 1. -1 plus 1 is 0. Alright, -6 turns into +6 minus 1, which is 5. And then you have your row 2, which is 0, 1, and -6. Now we have the matrix in reduced row echelon form. So we have a direct x value of 5. And you have a direct y value of -6. So the ordered pair that's going to represent the solution to this system where the lines intersect would be 5, -6. That is your solution, is 5, -6. And I should have 3 more. Alright, -2x minus y equals -5. (6x plus 5y is equal to 17. Alright, so there's our next system. Now let's convert this into a matrix to start with. So take the -2 on the x, the -1 on the y, then form your augmented line. Okay, put that -5 to the right of the augmented line. Now in your second row, take that 6 on the x, that 5 on the y, then put that 17 to the right of the augmented line. There's your matrix to represent the system. Now the first goal, of course, is to make that first digit in the second row become 0. So if I take 3 times row 1 and add that to row 2, I can make that happen. Alright, so 3 times -2 is -6. Add 6 to that, you'll get 0. Whoops, hold on. Let me leave row 1 alone here real quick. I forgot to write in row 1. We're not affecting row 1 just yet, but yes, -6 plus 6 is 0. So 3 times -1 is -3, plus 5 would be +2. And then 3 times -5 is -15, plus 17 would also be 2. Well, that's great. You have your first digit in row 2 as a 0, but your leading digit's a 2. It should be a 1. So that means to start with, let's take half of row 2. Alright, so that means for the time being, we're still leaving row 1 alone for now. That's about to change shortly, though. Alright, so half of 0 is 0, half of 2 is 1, half of 2 is also 1. Well, now we've reduced row 2 plenty, It's just fine, but the next goal is to make the second digit in row 1 a 0. Well, we can just straight up add row 2 to row 1 and achieve that. So take row 2 plus row 1 will achieve that goal. So 0 plus negative 2 is still negative 2. 1 minus 1 is 0. Alright, 1 minus 5 is negative 4. And then we're leaving row 2 itself alone because it's already reduced. Now we got a 0 as the second digit in the first row, that's great. But the leading digit in the first row is a negative 2. It should be a positive 1. So we need to take negative 1/2 of the first row. Let's go ahead and do that. So let's see, negative 1/2 of negative 2 is positive 1. Negative 1/2 of 0 still leaves it as 0. Negative 1/2 of negative 4 is positive 2. And then you just leave row 2 alone because it's already reduced. Now we have our matrix in reduced row echelon form, giving us a direct x value of 2 and a direct y value of 1. So the ordered pair that's the solution to this system is going to be the point 2, 1. And there would be your solution would be the point 2, 1. Should just have 2 more, then we'll be done with this lesson. Alright. We have, let's see, 9x minus 4y equals 2. Then we have negative 6x minus 16y is equal to negative 6. Okay. So let's go ahead, let's set up our matrix here. We will set this matrix up. So first row, take the 9 on the x, take the negative 4 on the y, then to the right of the augmented line would be that 2. And then your second row, take the negative 6 on the x, take the negative 16 on the y, then take the negative 6 for the right side. Okay, so there's the matrix that represents your solution. Always, always reduce the terms in an equation if you can. Look at your second row. You have negative 6, negative 16, negative 6. They all definitely have a common factor of 2, right? So what if I took 1/2 of row 2? We'll just simply start there. 1/2 of row 2. And do nothing else for a moment. The first row we're leaving alone. 9, negative 4, and then 2. Now 1/2 of row 2, 1/2 of negative 6 is negative 3. 1/2 of negative 16 is negative 8. 1/2 of 2, whoops, 1/2 of negative 16 is negative 8. I was going the wrong row. 1/2 of negative 6 is negative 3. So a little bit smaller numbers to work with. Now, we've reduced it. Oftentimes, when you reduce a row, the next thing you want to do before you try to make any numbers a 0 is swap rows. Swapping rows is considered an elementary row operation. It does not change your matrix, it just changes which row goes where, but you would get the same result. You would see if we got to determinants also, but anyway, we'll cover that at that time. But we're going to swap row 1 and row 2. There's a very good reason for that. So to swap rows, you're going to do a double arrow between the 2 rows. that denotes that you're swapping places with the rows. So let's do that. Now row 2 becomes row 1, so you'll have -3, -8, -3, and then row 1 became row 2, you'll have 9, -4, and 2. So there's your new matrix. We just simply swap the rows. It's going to be a lot easier this way, because now to make that first digit in row 2 0, all I got to do is take 3 times row 1 and add that to row 2. Had we not done that, I would have been taking row 1 and adding that to -3 times row 2, which to me seems a little bit tougher and you're more likely to make mistakes. That's why I swapped out rows after I reduced. So as I said, usually if you're reducing the coefficients in a row, you're often going to end up swapping rows. So if I just take 3 times row 1, add that to row 2, that should make the first digit in the second row a 0. So leave your first row alone for a moment. -3, -8, -3. Alright, so then 3 times -3 is -9, plus 9 is 0. Alright, 3 times -8 is going to be -24, minus 4 is -28. And then 3 times -3 is going to be -9, plus 2 would be -7. Alright, so the first digit in row 2 is a 0, but the leading digit's a -28. That should be a positive 1. So we got to take -1/28 of row 2. So let's go ahead and do that. So first row still left alone for a minute. Alright, so -1/28 of 0 still 0. -1/28 of -28 is positive 1. -1/28 of -7 would turn into positive 1/4. So now we have the second row reduced to how it needs to be. The next goal is going to be to make the second digit in the first row also become 0. If we take 8 times row 2 and add that to row 1, we can make that happen. So let's do that. 8 times 0 is still 0, plus -3, so you'll still have -3. 8 minus 8 is 0. Alright. 8 times 1/4 is 2, minus 3 is -1. And then you still have your second row of 0, 1, and 1/4. And now that's great. We have the second digit in row 2, second digit of row 1 as a 0, but it's still not in reduced row echelon form, because the leading digit in the first row is currently a -3, where it should be a positive 1. So let's take -1/3 times row 1, and we should get our desired form that we want. So -1/3 of -3 turns into positive 1. -1/3 of 0 is still 0. -1/3 of -1 is positive 1/3. And then you still have your second row of 0, 1, and 1/4. So this will give you a direct x value of 1/3, a direct y value of 1/4, which would make the ordered pair that's the solution to this system be 1/3, 1/4. That's where the two lines would intersect at the point 1/3, 1/4. Which reduced row echelon form is a lot nicer, especially when you're working with fractions, because if we were doing just basic row echelon form using back substitution, you're going to have to substitute the values of variables, then you're more likely to make a mistake doing the addition and subtraction. So in general, if you're going to use Gauss-Jordan elimination with elementary row operations to solve a matrix, to solve a system of equations, go straight for reduced row echelon form because there's no back substitution required. And you're a lot less likely to make simple math mistakes that way. And that's where sometimes people mess up, is just simply with the addition and subtraction step and misadding or subtracting something wrong. And it's easy to do. I've done it myself. It's like you understand the process, you just misadded or missubtracted, which it can happen to anyone. But reduced row echelon form reduces the chance of that. Alright, so here's the last problem. We have this system, negative 12x plus 15y equals 3, negative 7x minus 20y equals negative 4. Well, let's set up our matrix to begin with. So in the first row, the negative 12 on the x, the 15 on the y, and then to the right of the augmented line, you'll put the 3. And then take the negative 7 on the x, the negative 20 on the y, and then the negative 4 to the right of the augmented line. Okay. Well, look at your first equation. The first one, the negative 12, 15, and 3, the first row there, they all have a common factor of 3, don't they? The reason I'm saying that is because, once again, our goal is to get that first digit of the second row to be a 0. Well, do you really want to have to multiply the top row by negative 7 and the bottom row by 12? You're going to have huge numbers if you do that, especially when multiplying that negative 20 by 12. I don't think you want to work with 240 if you can help it. So let's go ahead. Let's take a third of row 1 to reduce some of the numbers. That's all we're doing to start with here. So just take 1/3 of row 1. So a third of negative 12 turns that into negative 4. A third of 15 is 5. And then a third of 3 is just 1. And then you still have your row 2, negative 7, negative 20, and negative 4. So, yes, it's still true we're going to make the first digit of the second row a 0, but now you only got to multiply the second row by 4 as opposed to 12. Much easier to work with. So, the goal is going to be here, what we're going to do is take negative 7 times row 1 plus 4 times row 2, and we'll do those operations, which will make the first digit in the second row a 0. Alright, so negative 7 times negative 4 is what? Positive 28. Plus 4 times negative 7, which is negative 28. 28 minus 28 is simply 0. Whoops, let me write in row 1 here, since we aren't changing that yet. My bad. So we got 0 for the first digit. Okay, great. Negative 7 times negative 7 times positive 5 is what? Negative 35. Plus 4 times negative 20, which is negative 80. Negative 35 minus negative 80 is going to be negative 115. Okay, and then negative 7 times 1 is negative 7. 4 times negative 4 is what? Negative 16. So negative 7 minus 16 is going to be negative 23. Alright, well, good start. We have the first digit in row 2 as a 0. But the leading digit's negative 115. It should be positive 1. So that means we're going to have to take negative 1/115th of row 2. So let's go ahead and do that. Alright. So once again, for the time being, leave row 1 alone. Okay, so negative 1/115th of 0 is 0. Negative 1 over 115 times negative 115 turns into positive 1. Negative 1 over 115 times negative 23, that would become positive 1/5. So we've now reduced row 2 to what it should be. The next goal is going to be to make that second digit in row 1 also 0. Well, if I take negative 5 times row 2 and add that to row 1, I can make that happen. So, alright, negative 5 times 0 is still 0, plus negative 4 is negative 4. Negative 5 plus 5 is 0. Alright, so negative 5 times 1/5 turns into negative 1 plus 1, which is actually 0 itself. And then you end up having, of course, row 2, which is going to be 0, 1, and 1/5. We're almost to reduced row echelon form, but not there. The leading digit in row 1 is a negative 4. It should be a positive 1. So just take negative 1/4 of row 1, which will end up giving you negative 1/4 and negative 4 is positive 1. Negative 1/4 of 0 is 0. And then negative 1/4 of 0 is 0. Then you still have row 2, 0, 1, and 1/5. So now you have this in reduced row echelon form, giving you a direct x value of 0, x equals 0, and then y equals 1/5. So the point of intersection is going to be the ordered pair 0, 1/5. That would be the ordered pair that represents a solution to this system, would be 0, 1/5. Alright, so that's it for the 2x2 matrices part 2. The next lesson we will do 3 variable systems of equations part 2. And we'll show you the identity matrix for a 3x3 system. So I hope everyone has a great day. Take care.